Okay, so today we are going to be looking at solid object-oriented programming principles. And I like to use a little story, and a little story will help you to remember each of these letters, and they're great for when you want to use it just every day. And maybe you're in an interview and someone asks you, do you know about solid design principles? And you can say, yes, I do. And all I like to remember it is using a little story of a little green stick man that's all alone in the desert. There's a big desert below him, and there's just sand. He's all alone, and the S in solid is for single responsibility. Now, the little stick man or your classes or your interfaces is only responsible for a single thing, for one thing. The little stick man can't be a bicycle or a car or a plane or a house or a restaurant, all together in one thing. So single responsibility, only does one thing. It's only a little stick man. The next is the O. The O stands for the open close principle, and the little stick man, once the little stick man class is created, he is closed for modification. So we're not going to be adding more arms and legs, because maybe it becomes a spider when we do that. I don't know how many legs I've drawn, and maybe he has two heads and there's something funny with him. It's best if he is closed for modification. However, by using object-oriented principles, we can give him hair extensions. The hair extensions is not part of the little stick man. It's a class that extends him, or an interface that extends him. Okay, then we're going to be looking at the L, and the L stands for the Lisk of substitution principle. Now he's very thirsty because he's been in the desert and he's been walking around there, and he wants to have a drink. And the Lisk of substitution principle says that if we have a drink interface, so we have a drink interface, he could have a glass of water, or he could have a cup of coffee, or he could have a glass of beer, or he could have a milkshake. And any child or parent, or if there's an I drink interface, anything that implements the drink interface, whether it's a child or a parent, should be easily substitutable to this little guy. So the little stick man doesn't really care about what gets past him. He can drink it. Anything that you give to him, he can drink. Okay, and then we look at the interface segregation principle. Now what that refers to is we're going to stick with this drink interface. So water may have a glass and water in it. Coffee may have a whole process. There's coffee beans and there's milk, and there's a machine that froths the milk and compresses the water and boils the water, and all the little things that happen in that coffee class. And the same with the beer. Someone's making the beer. There's hops and barley and yeast, and a process for making it. And the same with a milkshake. There's milk and strawberries or chocolate and ice cream, and there's a whole process of making it. Now, the interface segregation principle says that we shouldn't have one large interface. This is like a large iDrink interface. We should have lots of little interfaces. So iWater interface, and an iCoffee interface, and an iBeer interface, and an iMilkshake interface. Now, this just makes the management of each thing, and it's also to do with a single responsibility. So it's very confusing having one large drink interface, and if you are, for example, a fitness aware little stick man, that's a different type of stick man, and you just want to have a drink, but you don't want to see what's in the beer and the milkshake. You may have a black coffee and that's it, or a water, but if you're being passed this I drink interface, there's like so many things that's not relevant to you, that it becomes difficult to understand what's being passed to you and why. And it makes it much simpler if I just pass you a water or a coffee, and the rest of the things that you're not interested in, you don't even look at. Okay, and then the last one is the dependency inversion principle. Now, this little guy, little stick man, he is always, when he drinks something, going to a restaurant. He does not make the water or the glass of water. He does not make the coffee. He does not make the beer. He does not make the milkshake. Okay? He is at a restaurant. The waiter will bring him the drink that he's ordered. Now, the restaurant is a factory of some sort. Okay? Restaurant. And what this means is that each drink or each class that this little stickman consumes gets created not within the stickman class, but for example in the restaurant factory class. Now when you're testing, this makes it a lot easier. So if the little stickman had to create all the classes, so say it's a database connection, and the stickman creates a database connection, it means the stickman is dependent on the database connection to work. If it was an interface and a dependency inversion principle like dependency injection, for example, where the restaurant passes the drink in, the restaurant can have a different class for testing or different classes for testing that implement the same interface. So for example, if we wanted to pass an iCoffee in, now there could be the full iCoffee that's in the production system, and it's all the bells and whistles, and it's got like 100 things in it, or it could just be an iBlack coffee. But if it gets passed in and the little stickman doesn't create it, we don't create inherent dependencies in our structure, and that makes our code a lot cleaner, and we can much more easily create test code and use dependency injection frameworks, for example, to drive our design. Okay, I hope you enjoyed the story and that you remember this for your next interview or when you're using solid principles when you're designing stuff.